Hi, in this video, we're going to learn how to build your own chatbot CLI tool using the Gemini API. And we're going to start simple. The goal is for you to appreciate how communicating with API, LLM APIs really work. And if you're on a journey to become an AI engineer, how important some of these concepts are for you and how to plan when you are designing systems that leverage LLMs. So the goal of today's task is to build a chatbot, but we're going to use the CLI, which means that a command line interface. We are not building a UI. We are not building like a front end that people can interact with it. We'll interact through the command line interface. And we're saying that this CLI chatbot should run continuously and only exit. So when the user types the word exit, it should be able to take in the user's input. That means it sort of prompts the user to ask a question, then respond to it, and should send user input to the AI with context of the previous conversations. And I'm going to explain why this is essential. And it should be able to print the response of the AI. Then finally, as we said, it should exit when the user types exit. Let's go to the drawing board. All right. So if you are anywhere, when you want to build something like this, you usually have the UI interface or the interface where you're going to be receiving the prompts from the user. In our case, we are using the CLI, but then for a platform like ChatGPT, we have a UI, that's a user interface, that's a friendly user interface, but we are using the command line. Then we call the model through an API. Through an API, this video that we published, we looked at how to make this simple API calls. But the problem is that sometimes after I have made a simple API call to the model, I want to follow up and ask further questions based on the answer that I got. Maybe I didn't get clarity or I need more information. So I want to make follow-up questions. And that's how we naturally communicate or converse with our own folks or even with the LLMs that we have at our disposal. But unfortunately, these models themselves do not have memory. So these sort of intelligent models that we have unfortunately are not able to store anything in themselves. That means that when you, the AI engineer, is engineering a solution like this, you have to build in memory into your own application. So memory would be built into it from our code base itself. The application code is where we'll implement it. And there are several ways that you can implement your memory. The commonest way that you come across is using a database. So you can store all the conversations into the database, which means that whatever your user puts in, so we say user input, will be stored in the database, as well as the responses from the model will also be stored in the database. And that's how you'll be able to preserve the memory or preserve the history of the conversation. Also, the API through which we are making the call is stateless. What this means is that the API does also not remember anything. It does not remember that you just asked it to go and collect this information. In fact, it doesn't keep track of anything. It just does its work and forgets whatever it was asked to do. So you have to also manage the state. And that is one of the very important things that you need to understand when you're building with the LLM or the APIs offered by these LLMs. Very, very important for you. So how then do we orchestrate our chat application to be able to remember the conversation history? To be able to do that, we'll need to explicitly make every call that we're making to the LLM with the history. So if initially the user asked, or maybe you started by telling the LLM, my name is, say, Obed, right? If you told it my name is Obed and you asked it to, maybe when the first instance when you say my name is Obed, it might say to you, hi Obed. So this is the response, this is your input, this is the response. Then the next one, if you're going to ask, say, what is my name, and you expect it to remember your name, it will only remember it if you send both this initial question that you asked it together with this response that it gave you to it. So you always have to send the entire conversation as the request through the API to the LLM. For that reason, when we are structuring this request, there is some key things that we need to understand. One, we need to understand the role. So for every single message that we send, we would identify the role of who is sending that message. So in the case where I am telling the LLM that my name is Obed, the role becomes user. And this is almost the same across all the models that we'll be using across ChatGPT or GPT from OpenAI and Gemini from Google, Claude from Anthropic, any of them. Most of the time, you'd find that the role user is you or the end user who is using the product. Then we have the role assistant. The assistant is more of the model, and Google calls theirs model. So when we are using Gemini, you will see it as model and not assistant. But when you're using OpenAI, you see it as assistant. So essentially, it is more of a dictionary in Python where we have the role is user. Then we have the content or the message that this role is sending. So we're saying that this message came from a user, and the content of the message was, my name is Obed. That's the very first one. Then the subsequent one was the response that we received from the model itself. So that becomes role, depending on which model you're using. If you're using Google's own, then the role becomes model. But if you're using OpenAI's own, the role becomes assistant. So whichever one you put there, then you put the exact response as a content here as a content. So that becomes maybe hi Obed as a response that the LLM gave us. When we are making another request to ask the LLM, what is my name? We have to have this dictionary as a list. Okay, so usually you'd find should have written as well, but it's up to here where you have the role, that's the key, the value, key value in one dictionary, then this as well in another dictionary, right? So you pass the entire list of dictionary that states the role and the content for each of the items in the dictionary, then you send the entire thing. That means that if you have thousands of conversations, for you to be able to get a better response from the AI, you need to have all of the 1,000 conversations put together. Today, we are looking at Gemini, and how Gemini handles this is a bit easier. So there is an abstraction that Google has provided for us called the charts. So the charts implementation, or they call it the multi-conversation. I think that's how they call it. Let's look at their documentation. So to get their documentation, usually come to aistudio.google.com. Then we have this API quick start here. You click on it, it takes you to the documentation. Then under core capabilities, we are dealing with test right now. So you can click test. There are a lot of other ways. Yesterday's video, we looked at this way, but today we are looking at the chart, which is more of an abstraction. So if you come down here, you'd see the multi-turn conversation, which is called chat. So here, they've abstracted that for us so that instead of us manually piling up the conversation history, this will automatically do that for us behind the scene. So you would see here the note is chat functionality is only implemented as part of the SDKs. Behind the scenes, it still uses the generate content API for multi-turn conversations. The full conversation history is sent to the model with each follow-up turn. So this is more of an abstraction of what you would have naturally done yourself. This is the generate content API where you would have sent manually pile up the list of dictionaries of rows and content to the model. But since we have this implementation here, it becomes pretty easy. And that's what we're going to follow to implement. So in our code base now, the importance of these we described in yesterday's video, you can check it out. But OS and .env are models that will help us have access to our environment variables. And I've kept the API keys in this .env file. So that's where the environment variables are. So we load the .env, that means we make the environment variables that are in this file accessible on our computer so that our code can get access to it. Then we use the .os.getEnv to grab the actual value of our API key and pass it to this variable. Then this is no magic. It's just from the Google's implementation. If you take a look at it, it shows you that you need to initialize Gen A, which is their model. So you would have to install Gen A, Google Gen A. Then after installing it, you import it and you initialize this to client. Then when you initialize that to client, you can now create an instance of clients for the chats where you run it with client.chats.create. Then you pass the specific model that you want. So that's exactly what we've done here to be able to get the instance of the chat so that we'll use in our case. Since we want to build a tool that will continuously allow a user to input something, we start by running a loop with the while loop and we say while true. This means that it will always be true unless a condition in here breaks it. So while true, what we want to ask for the user's input. So we're using the input command, and the input command, we are passing u colon. That means that the prompt that we want the user to start writing from is u. And when we demonstrate it, you see exactly that. Then we pass the whatever we receive from the user, we pass it and check if user input is equal to exit. Remember we said that we should exit the application if the user types exit. So we are checking if the user typed exit, we'll just print goodbye. If they typed history, then we want to print the get history. The reason I added this line is so that we'll be able to see that indeed it powers up the conversation the exact way that I taught earlier, where we have a list of dictionary with the role and content. So we'll be able to see that. Then finally, if it is not exit and it is not history, then we'll go ahead and send it to the chatbot or to the LLM through this chat instance that we created. And the method is send message. So we are sending the message. And remember, I said behind the scene, this chat will handle all the history. So it would send all the history. If I show you an implementation in OpenAI's own, you would see it is a bit different where we have to manually manage the conversation ourselves. But this is a good abstraction. So if you want to really understand how it works, the way I explained it, you have to try with the OpenAI, and I'll record a new video on specifically about the OpenAI doing a similar implementation. But now we have this and we print the AI response. So to run this script, we can run Python, let's say this is in the directory video 2/chat_CLI. So we can run this, and the prompt, remember here we said while true input, then we have this u column. So that is what we are asking. Say what we wanted to tell it, my name is Obed. So that's what we told the LLM, and it says, nice to meet you, Obed. Then if I go ahead and ask, what is my name? It should remember it. It says, your name is Obed. So this tells me that it remembers. But you see, because we didn't manually add the conversation history, let's see if we can really get the history. If I type history, and this is where we are calling history, to get the entire conversation history, and I hit enter, it shows you exactly what Google is doing behind the scene for us. So Google has this whole thing, the user content, where it has put it into parts. The first one, the user content, the row here is user. And the text that is sent out there is my name is Obed. Since they are managing it, The structure is not entirely as we would have done if we're using the approach that we would have managed the conversation history. But you see the same thing that is happening. The role here is user. Then the response that came is nice to meet you, Obed. The role is model in this case. Then we go on with another, what is my name? The role is user. Then we get the content back is your name is Obed. The role is model. So this is one of the coolest ways to be able to build a conversational application using the Gemini model. And in the next video, we'll look at how to do a similar thing with the OpenAI model.